capacitors in series than in parallel. It will come ulta of resistance. Right. Derive expression for. Aryan saying, हेलो
Yes,
आर्यन,
sir. Yes, sir.
हैवी नहीं हो रहा है ना डोज?
नहीं नहीं sir.
अभी शायद थियरी स्ट्रांग हो गया होगा आपका ना थोड़ा.
Yes, sir. Yes, sir. अच्छा है सर.
हाँ, नो प्रॉब्लम, हो जाएगा. अच्छा, अभी इस पर टाइम मिला ना, खाली अच्छे से करो, घाई मत
Yes, sir.
करना कोई चीज. हाँ.
Yes.
Derive expression for equivalent capacitance in series. That means when n capacitors are in series, what is resultant capacity? Series means one after another. These two vertical line of same length is condenser or capacitor. One longer, one shorter is called battery. So two lines of same length is called condenser. This is C1, C2, C3. So consider three condensers of capacity C1, C2, C3 to be connected in series across battery of voltage V to supply constant current I. If current is constant, what about charge? Is it constant then? है ना? Charge is constant.
Yeah.
So charge on each plate will be Q. Will be same, that is Q. So this is charge Q, charge Q, charge Q. Let V1, comma V2, comma V3 be the potential difference across C1, C2, C3 respectively. Please draw this diagram. Consider three condensers of capacity C1, C2, C3 to be connected in series across battery of voltage V to supply constant current I. Let Q be the charge on each plate of condensers. Please copy till that.
Done, sir.
Yes. So three condensers C1, C2, C3 connected in series across battery of voltage V to supply constant current I. Let Q be the charge on each plate of condenser. Charge is same. What about voltage? Even that is same? No, no, no. In series voltage is not same. So I can say let V1 let V1 comma V2 comma V3 be the voltages across C1 comma C2 comma C3 respectively. C1 comma C2 comma C3 respectively. Respectively. Let CS be the let CS be the equivalent capacity in series. Capacity in series. Wait, let me complete till end. What is formula for capacity in general? C is Q by V. Correct na in
Yes, sir.
general? So if CS is total capacity, then Q is total charge, V is total voltage. From this, V is Q by CS I can write.
Yes, sir.
So V1 is charge same capacity C1, V2 charge same capacity C2, V3 charge same capacity C3. But total voltage is V1 plus V2 plus V3. So this will become Q upon Cs equal to Q upon C1 plus Q upon C2 plus Q upon C3. So Q upon Cs equals to Q common 1 upon C1 plus 1 upon C2 plus 1 upon C3 in bracket. Q cancel. So 1 upon Cs is 1 upon C1 plus 1 upon C2 plus 1 upon C3. I think now you follow. Hello?
Yeah, sir.
Yeah. Please copy it last line. So for three condenser, we proved 1 upon Cs equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Yes, done.
Yeah, sir.
Okay. So we have to now generalize for n condenser. For 3 we got answer. So I'm writing thus if n condensers are in series, then 1 upon Cs equals to 1 upon C1 plus 1 upon C2 dot 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 up to 1 upon Cn. Note, in series combination, resultant is lesser than least. Kamya, can you tell me what is meaning of this? Resultant is lesser than least.
So it means
Give some example.
it,
If 1, 2, 3, 4 are in series, result will be less than 1. है ना?
हाँ
Lesser than least मतलब सबसे कम is 1.
सबसे कम से भी
Answer will be
कम.
yes, yes. Now, if two condensers are in series, then I can write 1 upon Cs equal to 1 upon C1 plus 1 upon C2. So from this 1 upon Cs is C2 plus C1 upon C1 C2. So directly can I write Cs is product of C1 C2 upon sum? Can we write directly?
Yeah, sir.
Yes, sir.
So whenever it is two condensers in series and they ask resultant, you write directly product upon sum. Now copy poll, even note. Kamya, you focus on this electrostatic for at least 7 days. So that for electrostatic
हाँ
becomes
sir.
perfect. हाँ.
Yes sir.
उसके बाद करंट कर देंगे ऐसा perfect.
Okay sir.
Yes. This 12:30 you're not getting time na, to attend that batch?
So actually I don't even know because every night at 11 we get the schedule for the next day. It's not something which is regular. It's
Okay.
random.
Acha, acha. Because in that batch na, I'm doing this chapter only MCQs.
Yes sir, I know.
See, mostly I'm uploading all the lectures. So you please go on saying that.
हाँ sir, I do. I do.
Then it will become perfect. No need to attend that lecture.
Done, sir.
Derive expression for equivalent capacitance in parallel. Like we got series का answer 1 upon Cs is 1 upon C1 plus 1 upon C2 up to 1 upon Cn. Parallel will come C1 plus C2 up to Cn. One condenser of capacity C1 charge on its plate is Q1. Second condenser C2 charge on its plate will be different, Q2. Third one C3 charge will be Q3. Connected in parallel means one below another. Across battery again of voltage V to supply constant current I in outside circuit. At point A, current gets divided into three parts, I1, I2, I3. So that's why charges becomes Q1, Q2, Q3. Draw diagram. Can I clear this diagram?
Done, sir.
Done, sir.
Okay. So same history, right? Consider three condensers of capacity C1, comma C2, comma C3 to be connected in parallel across a battery of voltage V. Let Q1, Q2, Q3 be the charges on each plates of condenser C1, C2, C3 respectively. Let C P be the equivalent capacity and Q be the total charge. Now, total capacity means total charge upon total voltage. Hello?
Yes, sir.
So from this, charge is changing. So I'm separating charge is Cp into V. Just copy till this. Then we'll get Q1, Q2, Q3. Done now?
Yeah, sir.
So see basic what I am doing, whichever quantity is changing that I am separating and writing formula. So I will get Q1 as C1V is constant. Q2 is C2V. Q3 is C3. Total charge Q is Q1 plus Q2 plus Q3. That is CPV is C1V plus C2V plus C3V. So CPV, V common, C1 plus C2 plus C3. Both sides we cancel. So Cp equals to C1 plus C2 plus C3. Thus, if n condensers are in parallel, then Cp is C1 plus C2 up to Cm. In this case, what will be resultant? Greater than greatest? Resultant in parallel will be greater than greatest. So suppose they don't say which connection, but they say resultant should be greater. Then which combination will prefer? Parallel or series for condenser? Hello? See, sometimes they can give you. You are given with 3 condensers, 3, 2, 10. What will be the mode of connection to get the answer lesser than least?
Yes.
Series. And greater than greatest?
Parallel.
Parallel.
And then find resultant. So they will not give which connection, but they will say result they want greater or smaller. So if they want smaller, series. They want larger, parallel. Now complete till end.
Done, sir.
Right. Derive expression for energy stored between the plates of condenser. Heading written?
Yeah, sir.
Before we start derivation, small part. Is capacity of this parallel plate condenser constant or variable? Formula is A, K, epsilon 0 by D. Last lecture we proved. So it is constant or variable? See, area of plate is same, distance same, medium same, epsilon 0 same, then it will be constant only, na? C is constant, no? Hello? Hello?
Yes, sir.
So
Yes, sir.
if C is constant, then can I say this ratio Q upon V is constant?
Yes, sir.
Can I change Q or not? Is it possible?
No.
See, ratio is constant. We didn't say charge is constant.
Oh, yes, yes.
So like if charge is 10 and voltage is suppose 2, then this is 5. I can make charge 100 and voltage 20, still 5, na?
Yes, sir.
That means this charge and voltage will change, but ratio is not changing. This is the meaning of capacity. What is potential? Can I say this work done to move small charge? If I bring small charge, then small work will be done. Q charge, W will be the work done. ये dd न्यूमरेटर डिनोमिनेटर में अटैच कर दिया. So can you say dw will be v into dq by cross multiply? Hello?
Yes, sir.
So I will write this formula directly. अभी मैं क्या बता रहा हूँ आपको, मुझे एनर्जी चाहिए. एनर्जी मीन्स वर्क डन अगेंस्ट फोर्स चाहिए. So that means I'm interested in force, then work, and then total work which will be energy. Work I can write in potential also in case of electrostatic. Imagine these are two plates, no charge on this. When you bring first charge, will there be any opposition or not? सोच के बोलो ना फटाफट, क्या है इसमें? अभी पहला एक कुछ भी चार्ज नहीं था, तो आजू बाजू में इज देयर एनी फील्ड टू अपोज?
No.
No. But when this charge comes, there will be some electric field created.
Yes,
So,
sir.
so it will try to repel the bring additional extra charge similar. So that means whenever you start charging, that means there will be some repulsion created, but still we are depositing the charge. That means work is done against the repulsive force due to this existing charge. That work done gets stored in the medium between the two plates. इसका formula ढूंढने का है. Say suppose I take dumbbell and pull it against gravity many number of times. So automatically my body gets stored energy or not, because I'm investing my strength. Hello?
Yes,
Yeah,
sir.
sir.
अभी डंबल को उठाया तो डंबल की एनर्जी थोड़ी आता है, मेरा बॉडी के अंदर एनर्जी आ गया ना. तो चार्ज इधर आपने लेके आया तो इसके मीडियम के बीच में एनर्जी स्टोर हो जाता है. तो दिस का फॉर्मूला आई वांट टू फाइंड. सो फर्स्ट वी विल एक्सप्लेन व्हाई देयर इज एनर्जी स्टोर. सो व्हाइल चार्जिंग a condenser, work has to be done against repulsive force due to existing charges. This work done is stored in the form of energy between the plates of condenser. First paragraph, right? To explain from where this energy gets stored. So while charging a condenser, work has to be done against repulsive force due to existing charges. This work done is stored in the form of energy between the plates of condenser. Once you have completed writing, tell her. Finished writing?
Done, sir.
Let Q, comma V be total charge and voltage. Be total charge and voltage. So therefore capacity, comma C is Q upon V. From this I can say V is Q by C. C is constant. This Q and this V can change. ये total लिखा है Q and V. Let small q, comma small v be charge and voltage at any instant of charging. That means we assume total charge we can give is capital Q, total voltage capital V. So C becomes Q upon V, V is Q by C. But we are saying बीच में charge है, then if you bring extra, energy will be stored. So let Q V be the charge and voltage at any instant of charging. So if these are charge and voltage, so I can say small v is small q upon c. C is constant. So thus, in order to bring additional charge dq additional charge dq, work, second, thus in order to bring additional charge dq, work has to be done against repulsive force, against repulsive force due to existing charge q. Please copy till this. Let QV be the total charge and voltage. Capacity is Q by V. V is Q by C. Therefore, V is
Done, sir.
till end you have done due to existing charge
Yeah.
Q. Okay. Now we said work is done due to existing charge Q. So that formula for work done, small work done, dW will be VdQ. Correct? Now I explained how. So dW is V is Q by C into dQ. Total work done to charge from 0 to total charge Q, comma W is integration of dW from 0 to Q. Any doubt?
No, sir.
Now it is maths. This is equals to Q by C dQ from 0 to Q. So 1 by C Q dQ from 0 to Q. 1 by C q square by 2 is integration formula 0 to q. That is 1 by c q square upon 2 minus 0 square upon 2. So 1 by c q square by 2. That is nothing but half q square upon c. That is what this work done is energy stored. So that is energy stored denoted by U is half Q square upon C. Complete till this now.
Done, sir.
So that's all for today. Tomorrow you all don't have class. Directly we have lecture on Friday, same time.
Okay, sir.